This video is going to be rather short because I'm just going to go through the setup of the new archive capability for the Turbidostat system. So what I've done here is this is the standard Turbidostat, and I've simply added one more VI to it that you can turn on. Basically, we'll set one up here and we can turn on the visibility. Anyway, so this is an archiver. It's a rather simple archiver, and I'll go over the setup here. So let's just start this off by putting in a scan rate of 5 seconds. All right, so actually before I get too deep into it, I want to talk a little about what this archiver can do and what its intended uses are. This is a simple archiver in that it runs as a single thread, and what it will do is it has access to all the global variables that the Turbidostat has in it. What we do is we have an interactive setup where we basically put in the name for each column and then pick from the list of variables. For example, let's start out with something we'll call time here. And here we can decide what we're going to associate with it. And absolute time is a good idea to do this. And so now let's move through and do a few other columns. So let's put in here, let's say feed weight. We can type in whatever we want here. And we'll be using scale 0 for the feed. So we'll associate that with scale 0. And then we'll say feed pump. And we're doing pump 0 for that one there. And then let's say fermenter weight. Whoops, did that all go in? Yeah, actually, let's make that a little shorter because this is going to be a column in a spreadsheet. We use scale 2 for that. And then we'll do the drain weight, scale 1. Drain pump, pump 1. And then we can do, let's see, what do we have here? Drain weight, fermenter weight, feed pump, feed weight, time. Oh, no, we didn't put in relative time, but we can skip that one for now. Put in the OD, and we will select OD 0. So at this point now, we've got a bunch of columns defined for our output. And we have a scan rate, and I put in 5,000 milliseconds or 5 seconds. Now, because this is this is a single thread archiver, what it means is that it's going to write files using the same logical computational thread that it uses to gather data. Now, for other archivers that are a bit more sophisticated, like the ones we use for the ABEC system, the gathering of data from the running system and the writing to disks are two separate logical operations that are handled by actual different threads. And so what happens is that we can gather data while we're actually writing to disk. In this case, we can't. And so the idea is we have to have a scan rate that's slow enough to make sure that we can get our disk writing in the interval before we need to take more data, for example. If we made this number too small, if we made this number 1,000, it would probably still work because the machines are fast and can write a file within a second. But what would happen if it took too long to write a file, we would miss the next piece of data that we wanted to actually acquire from the system. So putting a number in here that's at least 2,000 milliseconds will ensure that that won't really happen. Now, file size here means how many samples we build up in the software before we write it to disk. Now, 1,000 is a reasonable size. We actually do several thousand, usually for the ABEX systems. The idea here is, well, we can make this 100 for now, but the idea is you put something in there that's big enough so that you're not dealing with a huge number of files, and small enough so that we don't wind up being vulnerable. So basically if we have a problem with the computer and the system crashes or something, we won't lose a tremendous amount of data. So the other thing too is we can put in a file name here. This is any file name. We could put in C /temp /test1. And what will happen is that just like in the ABEX systems, there'll be something appended to this name. So this is a base name. It should include the full path, but what the software will do is it will append the time of day to spreadsheet files, and XML files will simply get a numeric extension, so it's easier to put them together later. Clicking enable here means that as soon as the system starts, the archiver will start archiving. So unlike some of the other systems where there's a switch where you have to turn on, say, the feed VI and the drain VI, now the archiver will start running instantly. The other thing that one can do with the archiver is you can actually create several independent archivers. So this may not be well, obviously if we're running several different channels of the system at once, we might want separate archivers for each one. The other thing that we can do, of course, is if you wanted, for some reason, to have several different archivers looking at very similar data, you could just set them up. And I'm thinking basically this would be if you wanted very different scan rates for some reason, and you didn't feel like post-processing the spreadsheet files or that sort of thing. Now, the other thing that the archiver will do is that essentially it'll wait for a certain number of samples before it creates a file. Now, in the meantime, if you decide to stop the system, the archiver will notice this and write out the last partial set of data that it has to disk. Well, at this point, there's not really too much to say about the archiver. And while it's running, it doesn't really have much of an output, so it's not very useful to go through and fire the system up and demonstrate it running. What I did do is I ran it myself for the simulation runs that have been part of these demonstrations, and I forwarded that in an email for you to look at. So, at any rate, that's about all there is to say about the archiver at this point.